All right, guys, so in this video, we're going to talk about the idea of concavity and then really get into some formal curve sketching. In the last video, we did the first derivative test, increase, decrease, stuff like that. Now we're going to take it one step further and then really put it all together in our curve sketching. So to get things started, we're going to define what we mean by concave up and concave down. And I have the definitions up on the screen. If f prime is increasing on interval I, then f is concave up on that open interval I. Similarly, if f prime is decreasing on I, then f is concave down. Now, what's interesting about this is you probably need to take a step back a little bit and think what we're talking about. If the first derivative is increasing, in the last section we were talking about the function increasing and decreasing. To determine if the first derivative is increasing or decreasing, we would take a second derivative and then assess pluses and minuses to figure out if it is increasing and decreasing. So we're going to have a second derivative test here in a minute, which is going to allow us to find out if our function is concave up or concave down. So the idea of concave up, just let me draw a little picture here for you. Concave up would look something like this. CU concave up, something like that would be concave down. So in a physical interpretation, if the bowl would hold water, it would be considered concave up. If the bowl would empty water, it would be considered concave down. So we'll get to the second derivative test here in a minute, but right now I want to take a look at some graphs that I put together and really show you what we mean about these definitions of concave up and concave down. All right, so I've got two graphs up on the screen, and I have went ahead and color-coded them. The function on all of these is in red, the first derivative is in blue, and the second derivative is in green. So we know that this first picture here probably is pretty easy to understand because we've seen similar things before. If this is our function, you can see my function is increasing all the way to here, and then it turns to decreasing. So what should the derivative be doing? Well, if we're increasing, the derivative is positive, which means the derivative is above the x-axis. When the function becomes decreasing, now the derivative is below the x-axis, okay? And so then as we continue, and again, all the way here, from here to here, I'm below the x-axis. So my function is decreasing all the way to there. Notice how this x value and this x value here match up, okay? And then we turn to increasing from there on, and we increase above the x-axis from there on. Okay, so again, that's hopefully a little bit of a review, but now that we've talked about it, let's move over and talk about the second derivative. So the second derivative now talks about concavity. When that second derivative, f double prime of x, is bigger than 0, this is going to imply we are concave up, okay? If the second derivative is less than 0, this is going to imply we're concave down. So when we look at this now, we've got our second derivative that is less than 0 from there to there, right? All the way from negative infinity all the way to here. Our graph should be concave down, and it is. See how it's concave down right there? But then when our second derivative goes positive, right here, our second derivative is now above the x-axis, our graph should be concave up, like it is. Okay, so when the second derivative is below the x-axis, meaning negative, we're concave down. When the second derivative is above the x-axis, meaning positive, we're concave up. And this point, guys, right here, let me find a different color. This point right here, right? Just like over here, this was our critical value, that was a possible max or min. That was our critical value, that was a possible max or min. This guy right here that I'm marking, notice if I come straight down from there to about right there, this point is called an inflection point. An inflection point is where the concavity changes, okay? So what I have on the bottom of the screen, this more or less is your second derivative test. Much like the first derivative test, we're going to find the second derivative, we're going to put a number line together, putting our critical values on that number line, determining plus and minus, and that will give us both intervals of concavity from here and here, as well as these inflection points, these points where the concavity changes. So hopefully these two graphs helped out a little bit in understanding a little bit more about how the derivative and the second derivative, how their graphs relate to the actual function and where all this information is coming from.